You have seen this before. A molecular model. Little balls connected by little sticks. The balls are atoms, the sticks are chemical bonds. Simple, clean. Obvious, except those sticks are a lie. A chemical bond is not a physical thing. No one has ever seen one, no one ever can. The great theoretical chemist Charles Coulson put it bluntly. A chemical bond is not a real thing. It does not exist. It is a figment of our own imagination. A chemical bond is not a stick. It is not a string. It is a quantum mechanical effect. It is the result of a delicate dance of electrons and nuclei, and its nature changes depending on how and when you look at it. Welcome to Großdenken, everyone. Today we are going to take the sticks away and look at what a chemical bond really is. Please support this channel by just subscribing. That would mean a great help. For a long time, chemists knew that atoms stuck together, but they didn't know how. The American chemist Gilbert N. Lewis proposed the first successful model in 1916, the shared electron pair. Lewis said that atoms share electrons to achieve a full outer shell, like noble gases. In a covalent bond, each atom contributes one electron, and the pair is shared between them. But there was a huge problem. Electrons are negatively charged. They should repel each other. How could two negative charges form a binding link between two positive nuclei? Classical physics had no answer. The solution had to wait for the quantum revolution. The answer came in 1927 when physicists Heitler and London applied the new quantum mechanics to the simplest molecule, hydrogen. In quantum mechanics, electrons are not tiny billiard balls. They are waves, described by wave functions. A key fact: the kinetic energy of an electron decreases as the space it occupies gets larger. So, an electron wants to delocalize, to spread out. When two hydrogen atoms approach, each electron wave function can spread across both nuclei. This constructive interference lowers the kinetic energy of the electrons. This energy lowering is a major source of the bond's stability. This spreading of the wave function also builds up negative charge in the space between the two positive nuclei. This electron cloud acts like glue, attracting both nuclei and pulling them together. The bond is not a stick. It is this shared, lowered energy quantum state between the nuclei. But here is where it gets even more complicated. For decades, it was thought that the lowering of kinetic energy was the universal origin of all covalent bonds. A 2020 study in Nature Communications overturned this idea. The researchers found that for bonds between heavier atoms, like the carbon-carbon bond in ethane or the fluorine-fluorine bond, the kinetic energy increases when the bond forms. Why? Because heavier atoms have core electrons. Pauli repulsion between the bonding electrons and these core electrons forces the bonding electrons to become more localized, increasing their kinetic energy. The stick is still there, but the quantum mechanism that creates it is different. So, if a chemical bond is not one thing and we can't even see it, why do we still draw sticks? Because it is the most useful fiction in all of science. It is the glue that holds the entire discipline of chemistry together. Without the concept of bonds, chemists could not communicate about molecules, reactions, or the structure of matter. But remembering that it is a fiction is crucial. A bond is not static. It is an entity described by quantum mechanics that behaves differently depending on how and when we measure it. In ultra-fast chemistry, bonds are not just strong or weak. They are dynamic, stretching and weakening with every molecular vibration. So, what is a chemical bond? It is not a physical stick. It is a quantum effect, a lowering of energy driven by the wave-like properties of electrons. It is a figment of our imagination, but it is a figure we cannot do without. It is the convenient fiction that makes chemistry possible. Thanks for watching, and hit subscribe for more deep dives into the invisible world of chemistry.